Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve. Today we are going to do the variation of number of valence electrons across a period and down a group in modern periodic table.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
Now students, are you seeing this modern periodic table on your screen? Yes, it looks like this only, children. Now today we will be discussing about the valence electrons across a period and down a group. So basically children, what are valence electrons? First you need to know this. The electrons which are in the last shell, which is also known as valence shell, are known as valence electrons. This is the first point you need to understand about the valence electrons. Okay, so now we know this. Valence electrons are the electrons present in the outermost shell of an atom. So now let us study the variation of number of valence electrons across a period or down a group in the periodic table. Now let us go for across a period. Okay children, so first I would like to show you period number 1 over here. Now I would like to show period number 2 over here. Now children, if I discuss about the valence electrons in period 2, which is shown over here on the screen in the colored portion. So on moving from left to right across a period, listen to me very carefully children. On moving from left to right across a period, the number of valence electrons increases from 1 to 8. The variation of number of valence electrons is evident from the electronic configuration of elements belonging to second period. Now students, if you see period 2, which is shown on the screen, I see the elements as lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. We know this very well. So these are the elements belonging to period 2. Okay. What is its atomic number? We know how to place the elements in the periodic table now, and whatever is the serial number, that is only the atomic number. Yes children. Period 1 was hydrogen, helium, so its atomic number was 1, 2. But now we are doing period number 2, so it starts from 3 atomic number, 4, 5, 6, 7, 8, 9, 10. Right? We are knowing now about the atomic number. Correct. Now what is its electronic configuration? Okay. If we know the atomic number, we also know the electronic configuration. Lithium is atomic number 3, so 2, 1 is the electronic configuration, that is EC. Beryllium 4, so it is 2, 2, electronic configuration. So on, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7 and 2, 8. Okay. Now, after this, my next step is to know about the valence electrons. So I told you in the beginning, valence electrons are nothing but the electrons in the outermost shell. Okay. Let us go and check for period number 2 for all the elements. What? That is the valence electrons. So in lithium, we have valence electrons 1. How we came to know? Because of the electronic configuration. And how we came to know about the electronic configuration? Because we know the atomic number. Correct children? Okay. So lithium is having atomic number 3. So EC is 2, 1. So valence electrons 1. Because last shell is containing 1 electron. So valence electrons are 1. That is the last valence shell is having 1 electron. So the valence electrons are 1 only. Okay, beryllium, EC, that is electronic configuration 2, 2. Last shell is containing how many electrons? 2. So valence electrons 2. Same is the case with boron 2, 3. Valence electrons 3. Carbon 2,4, valence electrons 4. Nitrogen 2,5, valence electrons 5. Oxygen 2,6, valence electrons 6. Fluorine 2,7, valence electrons 7. Neon 2,8, valence electrons 8. This finishes your valence electrons in period 2. Okay, so from here we have concluded that the valence electron increases as we move from left to right. So this is the trend about the valence electrons in the modern periodic table. So this is one of the trend in the modern periodic table. Right, children? Okay, now let us come to the group, that is this. Okay, so here we are seeing group 1. That means going from top to bottom. Okay, on moving down the group, the number of valence electrons remains the same. Correct. For example, the number of valence electrons in all the elements of group 1 is 1. That is, the elements of group 1 will have the valence electrons 1 only. Okay, let us check out. Okay, so if I see this group number 1, I have these elements as you're seeing on the screen. Now, we also know the atomic number because we know in sequence the atomic numbers, and I told you the serial number is only the atomic number. But when we see group number 1, so the atomic number also we have come to know because we know how to place the elements in the modern periodic table. So, like suppose, let us check for this, children, over here in group number 1. That is, we are having 1 atomic number, 3, 11, and 19, and so on and on. So if we see, that is for lithium, 3, 11, and 19. If we take these 3 elements, let us check for the valence electrons. Now, if we see this lithium atomic number 3, so its electronic configuration is 2,1, right? Sodium is 11 atomic number, its EC is 281, correct? Now, if we see potassium atomic number 19, so its EC will be 2881. Now, when we compare all these 3 elements, so children, actually it will be same for all other elements also. But I'm taking these 3 elements to make you understand. Okay. Okay. So, now the valence electrons in lithium will be 1. In sodium will be 1. In potassium also it will be 1. But why? Because in the last shell, we are having electrons only and only 1. So that is why the valence electrons is also 1 in group number 1. So what is the conclusion over here? We have come to know that valence electrons remains the same as we move from top to bottom. If you know this concept, knowing the modern periodic table, you can go for any question, any trend, whatever comes in your exam, children. Clear? So this is all about the trend that is in the periodic table, that is of valence electrons. So keep on revising, children. God bless you. Take care. Bye-bye.